Okay, hello everyone. We are going to discuss a couple of questions today in this video. The first question that I'm going to discuss was posted in our group from our side, and there was another question posted by a student of mine in a particular group. So we're going to discuss these two questions today. So we'll start with the circular track problem. So I'll just read this out for you guys. So there are three people who are driving on a circular track. Their speeds are 20 km per hour, 30 and 25 respectively. So the slowest person is the only one traveling clockwise, and they all start from the same point on the track. Find a couple of things here. First is number of times they meet along the track in the first hour, and second is after how much time will they meet, and all of them meet at the starting point again. And the length of the track is given as 500 meters. So in these kind of questions, I mean, the basic idea is what is the ratio of speeds, and another thing that you have to understand is in which direction are they actually traveling. So we know that one person is traveling. Sorry, this was clockwise, right? So I'll just mark this here. So one person, the slowest one, is traveling clockwise, so that is 20, and the other two are traveling anti-clockwise with the speed of 25 and 30 respectively. Now, first thing, the number of times we meet along the track in the first hour. In order to get this, what we need to find is the number of distinct meeting points, and using that we can simply figure out the number of times they're going to meet, or let's say the time interval in which they are going to meet, and accordingly we can figure out the number of times they meet in the first hour. So quickly finding the speed ratio, simply we can just divide by 5, so you get 4:5:6. As this is the only person traveling and in opposite direction to the other two, so what we're going to do is we're going to take a minus sign here just to make this simple. Now what you do is you simply add take a difference of each of the cases, and then you can simply find the number of times the number of distinct meeting points along the track. So before taking a difference of these two, just check that this 5 and 6 has a difference of 1, right? So if this 5 and 6 is a difference of 1, that implies there is only one distinct meeting point. And always remember that the starting point has to be one of the distinct meeting points, provided they're starting from the same point. So if the starting point is one of the meeting, has to be one of the distinct meeting points, and there are only one distinct meeting point, so that automatically implies that these two people would always meet. Whenever they meet, they'll always meet at the starting point. And if all of them have to meet along the track in the first hour or whatever, if all of them have to meet, then what we need to do is we need to just use these two, right? I mean, if these two are meeting one time along the track, then there is no chance of all of them meeting anywhere else, right? And just remember this. I mean, somewhere down the line, all of them has to coincide in the starting point. So starting point has to be one of the distinct meeting points. I'm repeating what I said. So there will be one distinct meeting point of all of them combined. So if there is only one distinct meeting point, that is the starting point, and the rest of the part is easy. All you do is just take this 4, 5, and 6. So that implies when this person makes 4 rounds, this person takes 5 rounds, and this person takes 6 rounds, they're going to meet at the starting point. Now, again, the whole, you can now the rest of it you can figure out using any one of them. So let's take the first one only. So the first one is traveling 4 rounds, covering 4 rounds and then meeting. Length of the track is 500. So that means the first person, the slowest one that is, would cover this much, and that is 2 kilometers. This 500 meters, by the way. So that is 2 kilometers, and all of them meet at the starting point. Now, how much time would this person take to cover 2 kilometers? We know that the speed of this person is 20 km per hour. So simply divide, you get 1/10 of an hour. And we don't need to convert it to minutes, just use this 1/10 of an hour. We need to find how many times should we meet in the first hour, right? So if they're meeting after every 1/10 of an hour, in the first hour, they're going to meet 10 times. So that's the answer for the first part. And second part is asking after how much time they all meet at the starting point again. We already figured this out in the previous question, right? So previous question answer is this thing. I'm sorry, second question answer is this thing, the 1/10 of an hour. So basically they all meet at the starting point again after 1/10 of an hour, which is 6 minutes. So the first question's answer is 10 times and the second question's answer is 6 minutes. So that is the first question. We'll move to the second one now. Okay, so this is a cryptarithmetic, whichever way you call it, these kind of questions. See, in these kind of questions, it's very important that you view it in a way of column, and apart from that, other observations also comes in. So I'll just quickly go through few observations that I made while solving this. So just quickly noting this down. There's 0 here. D, E, D, B, C. So first I'll just use this multiplication here. Now first thing to notice here is this thing. This C into B is giving us C, right? A last digit of C. Now you can remember this. There are a couple of things that happens. One is anything multiplied. So basically what we can say is anything multiplied to 1 ends with the same last digit, right? In fact, ends with the same number. So if in case B is 1, then this property would definitely happen, right? C into 1 will definitely be C. Another thing that might happen is that C is an even number and B is 6. So if you take this idea here, say suppose let us say 4 into 6. 4 into 6 is 24. If you check, the last digit is matching, right? So this couple of things you can remember, and there's a reason for this. I'm not going into that. This basically you can just check 4 into 5 as the last digit of 0. I'll give you a hint. Try to figure it out yourself from there. So a couple of things can happen. Either B is 1 or B is 6, and in case B is 6, C has to be even. Okay, so that is the condition for B to be 6. Now the problem with B being 6 is that if you look at the next multiplication, the next row or the next column, that is. Now C into B, if B is even, if B is 6 and C is even, in that case there will be some carryover. Now if you check anything, I mean the lowest possible value of C, I mean even 2. 2 into 6 would give us ending with 2, right? And here also 2 into 6, but that can never end with 2. The other thing that might have happened is that C is 0. But there is a problem with C being 0. I'll leave that for you guys to figure it out. There is a problem with C being 0. I'll not give that away right away. So eliminating that possibility, so we are left out with only one possibility, that is B is equal to 1. And if B is equal to 1, then this multiplication is somewhat like this: A11 into AC is giving me something, right? Again, if you look at this particular row, see what is happening here. We are getting, I mean, where is this row coming from? It is coming from this, right? A11 times A. So we can say that A11 when multiplied to A will give us DBAA. Now forget about this A, because that will anyhow come from A into 1 and A into 1. But then what about this D and B here? We already know that B is 1, right? So here there has to be a 1 and there has to be a D here. Now see, A into 11, just break this in this way. This is like A100 plus 11 and you're multiplying an A to this. 11 into A will give us A, that is fine, for any A it will work. But then A100 into A, or this A into A, should be basically D1. Now I hope everybody knows that 9 square is 81, right? So this works for 9 square. This is the only thing that works here. So we can quickly say that A is 9 and D is 8. So that is what we get here. So first thing that we observe from here is that A is 9. This is 1 1. This A would also be 9. And the left out thing is C. If we can somehow figure out C, then this multiplication is complete, right? We can figure everything out from here. We can simply multiply and get all the values. So in order to get the value of C, if you look at this column here, always focus on the values that you already know, something like Sudoku. So A and B are already known to us, right? See, the C plus 0 is giving us C. So this column is not giving us any carryover. Carryover is something you have to always keep in mind. So C plus 0, C, that is not giving us any carryover. So simply C added to A ends with the last digit of B. Now think about the values. We already know that B is 1. So this thing has to be 1 here. We already know that A is 9. So what plus 9 will end with 1? Simply 2, right? So what we get is, this is the multiplication. The first multiplication is achieved. We already figured this out. Now for the second part, I'm going to erase this all. You can move forward and backward in the video to have a check. So I'll just quickly erase this. Okay, I'll also keep a note of, or do I need it? Okay, I don't think I need it. Anyhow, if I need it, I'll just keep a note of it. Now, I'll just take this whole thing down. So ECF into AF is giving us BCAG. And here we have CA, BG and 0. Again, I focused on the values that I already know. I know that B is 1. I know that A is 9. I know that C is 2. And I also know that D is 8. Remember that 81 thing. So I know these values. D is not featuring anyhow here. This is giving us this E, I, F, H and G. Now, if you look at this multiplication here, C is known, A is known. If we can somehow figure out F and E, our job is done, right? Now, check this out here. What is the value of A? The value of A is 9, right? And the thing is, G cannot be 0. We can straight away eliminate the scenario with G is 0, because if G is 0, then look at this last column multiplication. F into F must end with a 0, so F has to be 0 itself. So both of these letters cannot be 0. They've mentioned that they're different integers. Each of the letters are different integers. Always in these kind of questions, you'll have different integers. So G cannot be 0. So basically, even if G is 1, there is a carryover here, right? Because A is 9. Even if G is 1, then A has to push a carry. So whatever carry is pushed, this is 1 pushed here. C is 2. B is 1. So that implies F must be 4. So one thing we have already achieved. Another thing, if you look at this last column here, C is changing to E. What can be the maximum carry pushed here? Maximum carry that we can push here is 1. We can even use the values. We already know the values. But I'm just saying, I mean, we are adding 2 digits, right? What is the maximum carry that we can push? We can push a maximum of 1. So basically what we know is C plus 1 is E. And we know the value of C, that gives us E is equal to 3. So once we know that F and E, our job is done again. So this multiplication is 3, 2, 4 into 94. And just multiply to get everything here. So that's it. Thank you for joining in. Please subscribe and like the video.